Welcome to a cosmic journey that'll blow your mind. Picture this, the universe as we know it, 13.8 billion years of stars, galaxies, and everything, might not be the whole story. What if it's just one chapter in an endless book of universes? Today, we're diving into some wild ideas about where it all came from, sparked by jaw-dropping discoveries from the James Webb Space Telescope, JWST for short. This incredible machine has spotted galaxies from the dawn of time, just 200 to 500 million years after the Big Bang, and they're way more massive and structured than anyone expected. It's got people asking, could these be leftovers from a universe before ours? To figure that out, we'll explore the classic Big Bang theory, two mind-bending alternatives, the Ekpyrotic model and Conformal Cyclic Cosmology, and why they ditched the idea of a big crunch. Buckle up, because we're about to question reality itself. Let's start with the Big Bang, the story most of us know. About 13.8 billion years ago, everything, space, time, matter, exploded from a single, infinitely dense point called a singularity. No one knows what came before, if before even makes sense, because time itself began there. The universe expanded, cooled, and eventually formed stars and galaxies. But here's a problem. The early universe was weirdly smooth and uniform, almost too perfect. To fix that, scientists cooked up cosmic inflation, a superfast stretch right after the Big Bang that smoothed things out. It works, but it's a bit of a fudge. And then there's the big crunch idea. What if the universe stops expanding and collapses back into a singularity? For decades, that was a contender for how it all might end, or restart. But the discovery of dark energy in the late 90s flipped the script. It's pushing the universe to expand faster and faster, likely forever, killing the big crunch chances in the standard model. Still, the Big Bang leaves questions, like what sparked it, and could anything survive from a before? Enter JWST, our cosmic time machine. Launched in 2021, it's peering deeper into space, and thus further back in time, than ever before. What it's found is unreal, galaxies at redshifts of 10 to 15, meaning their light's been traveling for over 13 billion years. These aren't just blobs, they've got disks, maybe even spiral arms, and they're packed with stars. Some are as massive as our Milky Way, formed when the universe was less than 5% of its current age. Scientists expected tiny, chaotic star clumps, not this. It's like finding a fully built city in the Stone Age. Naturally, people are buzzing, could these be relics from a previous universe? To explore that, we need to ditch the standard playbook and look at two radical theories that rethink the Big Bang and the Big Crunch entirely. First up, the Ekpyrotic model. This one's straight out of sci-fi, and it's awesome. Imagine our universe isn't alone, it's a 3D brain, a giant membrane, floating in a higher dimensional space called the bulk. Nearby, there's another brain, a parallel reality. Over trillions of years, hidden forces, maybe from string theory, pull these brands together. Then, BAM. They collide, and that crash releases a flood of energy, sparking a new universe, our Big Bang, but without a singularity. This idea, dreamed up by physicists like Paul Steinhardt and Neil Turok, says the universe's smoothness comes from the brand's properties before they hit, no inflation needed. Here's the kicker, it's cyclic. After our universe expands and fades, the brands drift apart, then crash again, birthing another universe. No big crunch here, the cycle doesn't rely on collapse, just endless collisions in higher dimensions. It's elegant, wild, and makes you wonder, could those early galaxies be echoes of a past cycle? Now, let's pivot to Roger Penrose's Conformal Cyclic Cosmology, CCC for short. This Nobel Prize-winning physicist says the universe doesn't need brands or crashes, it's all about stretching and looping. Here's the gist, our universe expands forever, driven by dark energy, until all matter decays into light and space flattens out. Sounds like the end, right? Nope. Penrose argues that when everything's just photons, space and time lose meaning, big and small become the same. That infinite, stretched-out state resets into a new Big Bang, perfectly scaled to start over. It's a cycle, but not like the Big Crunch, no collapse, just a smooth transition from one eon to the next. Penrose even claims we might see hints of past eons in the cosmic microwave background, faint rings from ancient black holes. Could JWST's galaxies be from one of those prior eons? It's a stretch, but it's tantalizing. So, how do these ideas stack up against JWST's early galaxies? Let's dig into the data. These galaxies, think names like Glass Z13 or CERS 93316, are young by cosmic standards, formed 200 to 500 million years post-Big Bang. Their light's redshifted so much it shifted into the infrared, which is why JWST is perfect for spotting them. They're bright, meaning tons of star formation, and compact, but some show surprising order, disks, maybe arms. In the standard Big Bang model, this is puzzling. Galaxy formation should take time, dark matter clumps, gas collapses, stars ignite. Yet here they are, fully dressed for the cosmic party way too soon. Some say it's just faster physics, maybe black holes seeded them early, or star formation was super efficient. Others whisper, what if they're older than we think, from a before? Here's where the Ekpyrotic model comes back. If universes cycle via brane collisions, could these galaxies be survivors from the last one? Probably not. The model says each collision wipes the slate clean, the energy obliterates everything, resetting matter into a hot, dense soup that becomes our Big Bang. No galaxies would survive that, they'd be reborn from scratch. The smoothness and flatness JWST sees match the Ekpyrotic prediction, but the galaxies themselves fit our universe's timeline, no need for a pre-Big Bang origin. Still, the cyclic idea teases us, if the brands carry subtle imprints, could future tech spot them? For now, it's a long shot, these galaxies look like homegrown products of our own cosmic dawn. What about CCC? Penrose's cycles don't involve physical leftovers like galaxies crossing over. Each eon ends in a featureless sea of light, and the new one starts fresh. The only remains might be those CMB rings, called Hawking points, which Penrose claims he's found, though most scientists aren't convinced. JWST's galaxies don't show anything wild enough to suggest they're from a past eon. Their chemistry, low in heavy elements, screams young, not ancient relic. If CCC's right, the transition between cycles is too clean for whole galaxies to slip through. These early beasts are likely just our universe flexing its muscles, forming faster than we thought possible. Let's zoom out and tackle the Big Crunch rejection head-on. In the old days, cosmologists thought gravity might pull the universe back into a singularity, a big crunch, maybe even kicking off a new Big Bang. But dark energy's acceleration says no dice, we're headed for a cold, empty forever. The Ekpyrotic model sidesteps this, its cycles don't need collapse, just brane crashes in the bulk, happening regardless of expansion. CCC does the same, no crunch, just a clever reset when the universe gets too big and flat. Both ditch the Big Crunch's messy implosion for smoother, more creative rebirths. JWST's data backs the expansion story, those early galaxies fit a universe that's been stretching since the start, not one poised to shrink. So, can these galaxies be remains from an old universe? The evidence says no, they're too tied to our Big Bang's timeline. Their redshift, their starlight, their structure, all point to a post-Bang origin, maybe accelerated by quirks we don't yet get. The Ekpyrotic model and CCC offer epic before stories, but neither predicts physical leftovers like galaxies surviving the reset. Still, JWST's shaking things up. If it keeps finding oddities, say, galaxies with impossible ages or bizarre patterns, those theories might get a second look. For now, these cosmic toddlers are likely our own, born in a universe that's younger than it looks. We've covered a lot of JWST's stunning finds, the Big Bang's limits, brain-smashing cycles, and Penrose's infinite loops. The universe is weirder than we ever imagined, and we're just scratching the surface. What do you think? Could there be a before? Are these galaxies hiding secrets we can't yet crack? Drop your thoughts in the comments, I read every one. If you loved this cosmic ride, hit that subscribe button and ring the bell, we've got more mind-blowing mysteries coming your way. Thanks for watching, and let's keep exploring the unknown together.